Thank you. Is this thing on? My name is Sam Sweberg, and I'm a rising senior at NDSU. I'm majoring in computer engineering. In these past 2 semesters, I've been working on our sim racing system project for senior design. The reason I picked computer engineering is because I like making stuff cool and I want to be Iron Man someday. And so this is the first step onto that goal. I started taking an interest in electronics and electrical engineering probably my junior year of high school, right when quarantine hit for COVID. I had a lot of free time, and that's my first project was the Internet of Things smart switch, since I was too lazy to go turn off a light in my room. And then now we're here making a sim racing wheel. When I first joined college, my goal was to be able to make and interact with electricity and kind of just do whatever I want with it. And so before, you know nothing about circuits, you just know what electricity is at the basics. And so it's kind of amazing to think back at the journey I've had over these past 4 years, going from not knowing anything, learning the basic Ohm's law, and now being able to make something from my imagination into real life that is pretty complex and kind of hard to believe that you can even do something like this in such a small non-company environment with just a 3D printer, a computer, and a lot of time. This project was not on the professor's faculty list. We went up to him ourselves and proposed it, and he thought it was a great idea, especially since it was a student idea instead of a faculty. He thought we'd be a lot more passionate about it, which is definitely true, as you can see on my shirt. We started working on it about September, when the semester started last year, since it's a year-long project. So on the steering wheel, we have up to 10 buttons here, and they're just general purpose buttons. For example, the user can set them to whatever they want in the game. So for example, this one could be pit limiter, this one could be DRS if we're playing a Formula 1 car. These encoders, we have 3 encoders here. For example, these can change the ABS settings on a car. This could be traction control. In the middle, we have our gear selector. At the bottom, we have our speed. On the top, we have our RPM, along with a bar as well. We do in software support using a NeoPixel, but for this demo example, we do not have that in there. The software supports up to 4 paddles in the back for shift and clutch, but for this demo example, we only have shift paddles. For the pedals over here, it supports up to 3, but we are only using 2 since it's a racing style one for formula. And so we have throttle and brake, but in software we do support clutch as well. The system was fully modeled in Fusion 360 CAD and was mostly 3D printed except for the aluminum frame and other mechanical parts like that. The components inside the wheelbase include the microcontroller, an H-bridge to drive the motor, the DC motor itself, and a Hall sensor that we use to detect the absolute 0 angle since our rotary encoder is incremental. The biggest challenge was it was a project where in other classes I would not really, or I would know how to kind of do it after thinking about it in a couple minutes. You kind of knew how to get to the finish line. For this project, I didn't know how to get to the finish line. For example, for getting the device to be recognized as Windows Game Control, I had no clue how to do that before, and I didn't even know where I would begin to find that out. But that was the whole thing. There was a lot of unknowns, and that was kind of the fun part. In the end, we were very proud of this project, what we were able to accomplish. At first, we were not sure if we would be able to hit all 3 goals, but in the end, we figured it out and got it done.